A new store must hire 3 cashiers and 4 store clerks. There are 7 applicants for cashier and 8 applicants for store clerks. How many ways can this be done? It's going to be interesting because this is going to combine a bit of the fundamental counting principle and combinations at the same time. So the reason it's going to combine both is because if the question was just hiring cashiers, would you agree that the number of ways you could hire cashiers would be 7, choose 3? That's your number of choices for cashiers, because the order doesn't matter how they're hired. But we have a second thing we have to decide as well. We also have to decide how many clerks there are going to be. That's a second decision. You have to decide on who your cashiers are, and you have to decide on who your clerks are. So this is very similar to the fundamental counting principle with decisions. How many choices, though, do we have for clerks? Well, there's 8 applicants there, and we need to choose 4 of them. What's the difference between a cashier and a clerk? Does anybody work in a store that, probably worked in a store that has a cashier, but does anybody work in a store that had a clerk? What does clerk do? Make sure everything's going good, make sure the shelves are stocked and stuff like that. Okay. But isn't the word clerk kind of like, you ever have those English words where if you say them, you say them over and over again, they start to sound like that's not really a word? It's real, I think, clerk. That's weird. It's a weird word. Anyways, so what should I do between these? Should I add or should I multiply? What did we do with decisions? Did we add in between decisions or did we multiply? We multiply. Okay, we're going to get the possibility in this unit for confusion is good because you have now a bunch of different strategies, right? When did we add? We added when we counted things as separate cases. When do we multiply? We multiply when we have separate decisions that get put together. These aren't separate cases because just hiring cashiers isn't a whole thing on its own. So we have to multiply in between. I guess if you went to your calculator and got the answer, this is 2,450 different ways.
Majority of these units calculator.
Yes, majority of this unit's calculator. Sometimes if the numbers are smaller, then you could, like, technically, this could be asked of you without a calculator. 7, choose 3. Why? Because you would have, and what other number on the bottom? 4. And then how do we simplify factorials? We expand the bigger one, so you go 7 times 6 times 5, until you get to 1 on the bottom, and then you stop and go, hey, wait a minute, that's going to cancel out with that 4, and I still have a 3 factorial. Could I simplify this? Well, this is 7 times 6 times 5. 3 factorial is 3 times 2 times 1. Can you see the 3 times 2 makes 6? And that would cancel out. And so the biggest mental math we have to do is 7 times 5, which is 35. So this could be asked of you without a calculator. And 8, choose 4. You could do that one as well. You're going to get a bigger number than 35. It's doable. But then to do 35 times whatever other number to get 2,450, probably not. Right? Then the calculator would be necessary. I have seen this on a non-calculator part of the question where they wrote a multiple choice and the final answer looked like this. Can you see what they did? These are all 4s. I know they look terrible. Right? Because the 7 choose 3 is 7 factorial over 3 factorial, 4 factorial. 8 choose 4 would be 8 factorial over 4 factorial, 4 factorial, and they just put it as one big fraction. Could you do that without a calculator? Yes. So I have seen that on exams that way. Okay, questions for this one? 12, 13, 14, 15, and 16. like to do number 15 together with you right now. So let's open that up. And the reason I wanted to do number 15 with you is if you got A on a test, most likely A would say solve algebraically. And that means we have to use the formula and we have to do mathematics to figure it out. So using the formula, this would have an n factorial and a 2 factorial. What would go with it? Right? The bottom two have to add up to the top one. What goes here so that the bottom two add up to the top? N minus 2. And we still have a 28 on this side. Now 2 factorial is equal to 2, so I can multiply both sides by 2 and get 56. Now how do we simplify factorials? We expand the bigger one. So you have to decide which is bigger, n or n minus 2. Right? And if you're ever unsure, pick a number for n. What's bigger, 7 or 7 minus 2, which is 5? What's bigger, 7 or 5? That's an easy question. 7 is bigger. So obviously the n would be bigger. If I plugged in a number, it becomes obvious. So we start expanding the bigger one, n. What's 1 less than n? N minus 1. What's 1 less than n minus 1? N minus 2. And when I get to n minus 2, I say, hey, wait a minute, that's what's on the bottom. It's equal to 56. These n minus 2 now, they would simplify and go away. And now I have a quadratic equation, because this will be n squared minus n equals 56. I'd probably say, let's move it over and make one side equal to 0, so we can factor n and n. Two numbers that make 56, so that the outside and inside makes 1. 8 and 7. And to make a minus 1, the 8 would have to be negative, and the 7 would have to be positive. So we get two answers, n equals 8 and n equals negative 7. It is impossible to have negative factorials. You have to put an x through that. It is not okay just to, by the way, on the exam, this is the right answer, n equals 8. If you knew that was the right answer and knew this one was negative and just did this, you would lose marks. They say on the final exam, they need to show that you see the answer and know that it's not the right answer with an X through it. It is not okay just to write the right answer and circle. So we get n is equal to 8. So if you had part A would be algebraic. Okay? Algebraically almost always happens when there's a 2. B would not be algebraically. We're going to do B together. N choose 4 equals 35. I'm going to write it out as I'm going to start with my formula. Okay, n minus 4. I'm going to multiply both sides by the 4 factorial. Are you okay that 4 factorial is 24? So I'm going to just write 24. I'm not actually going to multiply 35 times 24 because I don't know what the answer is without my calculator. But I'll leave it as 35 times 24. So I'm starting by solving this algebraically, just like last time. I expand the bigger one, n. 1 less is n minus 1, 1 less is n minus 2, 1 less is n minus 3, 1 less is n minus 4. And then I'd be like, hey, that's what's on the bottom. So I can put the exclamation with that because it would keep going, but this will cancel out. And this is still equal to 35. Now there is an algebraic way to solve this. It would involve the following. You would have to multiply out the n minus 1, the n minus 2, and the n minus 3 together. Do you see that that would give you an n to the power of 4 equation? You'd have to multiply the 35 by 24 out, so it'll give you a big number, and move it over to the other side to make it equal 0. And you'd have a very big number with an n to the 4, and you'd have to use the factor theorem and remainder theorem and synthetic division to try to factor that. And it would take a very long time and be painful. So in these examples, though, I'm going to show you a little bit of a shortcut that doesn't involve that. And the shortcut looks like this. First of all, on the left, do you see that you have 4 numbers multiplied together? Number 1 times number 2 times number 3 times number 4. And those 4 numbers start with a big number and go down by 1 each time. Do you see how that works on the left? I'm going to use that to my advantage. I'm going to see if there are ways that I can break up the numbers on the right-hand side and hopefully rearrange them, once they're broken up, to be 4 numbers in a row. What can you break up 35? What times what? 7 times 5. Oh, 24 is 6 times 4. Do we have 4 numbers in a row? 7 times 6 times 5 times 4. So n is equal to 7 because n is the biggest one. Isn't that way better than the factor theorem, remainder theorem, synthetic division, and 3 hours of your life gone? Yes. Okay. Now, would you be allowed to do this if the question said algebraically? No. If it says algebraically, you will get a 2. And the 2 will be very easy to solve for. If the number is bigger than 2, then I'd say don't do it algebraically, that takes too long. It is possible, but you would have had to figure out 7 with synthetic division. You know how many numbers you would have tried first before you probably tried 7? Lots. So I just wanted to show you both of those techniques, because if you tried this one algebraically, you would have given up. But the first one definitely can be done algebraically. But B, C, and D, I would all do using other strategies.